Let's see if we can broaden our understanding of how we can use substitution to find antiderivatives. So I've got three different integrals here, and we're going to use substitution on each one. Now, we'll start off with the first one. This one is kind of a classic substitution integral because notice we've got an x squared plus 1 raised to the 7th, and then we have an x over here. And we know if we take the derivative of x squared, we're going to get 2x. So this is just perfect. We've got x to the first power here, x to the second here. So if I let u be x squared plus 1, then du is 2x dx. And of course, we don't have a 2x dx, we have an x dx. So what you might do is divide by 2, and you find that x dx can be replaced by du over 2. So I'll do that now. I've got du over 2, so I'll just put the 1/2 out front, and inside here I'm going to put u to the 7th du. Yeah, because notice x dx, that's replaced by du over 2, and then I've got x squared plus 1, that's just u raised to the 7th. So now it's simple for us to find the antiderivative. We can just simply say, okay, this is 1/2, this is times 1/8 u to the 8th plus c. And there we have it. And, you know, of course, we probably want to say, well, this is 1/16 u to the 8th plus c. And if you want, you can substitute back in. So this is x squared plus 1 to the 8th plus c. And there we have it. So this is classically the way we would use substitution. Let u be something, then find du, and what do you know? That's the rest of it, and then we substitute back in. But that was possible because this was x squared and this was x. This was to the second power, this was to the first. But what about this one? They're both to the first power. Can we still use substitution? Well, let's see. Let's let u be x plus 1. And now, if I find du, look at du here. Du is just equal to dx. But what about that x right there? We still have that x. And it's hard to see from this how we can substitute in nicely like we did with this problem. So here's what we can do. I'll let u be x plus 1, and then I can just solve for x. Now let's see what we have. We have the integral of x, which is u minus 1. See? And then x plus 1, that's u to the 7th du. Oh, well, this is an integral that we can solve. So let me distribute the u to the 7th through, and I get u to the 8th minus u to the 7th. And this is easy. This is easy for us, right? Because this is just going to be 1/9 u to the 9th minus 1/8 u to the 8th plus c. So we've found this integral using substitution, but it required us to, you know, to handle the substitution a little bit differently than we did up here. See? So we needed to solve for x. Okay? Now that's a couple of examples. Now let's look at this one. Now, this one, of course, is very similar to this, but I notice it's got a square root in it. And a lot of times, if I'm integrating, I would rather not have to deal with a fractional exponent, like, you know, u to the 1/2 or something like that. So what I might want to do is just let u be the entire radical, the entire square root. Now, if I do that, notice what I can do next. I can say, well, then u squared is equal to x plus 1. Now I can find du. So du, you know, differentiate implicitly. So this would be 2u du equals dx. Okay. Now, also note this, that x is equal to u squared minus 1. See, just solving for x here. Now, let's see what we've got. We've got, in place of x, I'm going to put u squared minus 1. See, that's x. And in place of the square root of x plus 1, I'm going to put u. And then in place of dx, I'm going to put 2u du. Now, this is nice because we don't have any of those fractional exponents. So this should be a little bit easier. So let's see what we have now. Let me work it out a step at a time. This is u squared minus 1. And I'll put the constant, the 2 on the outside, times u squared. See? I just multiplied the u's together, put the constant on the outside. And now let's see what we have here. We have u to the 4th minus u squared. Now this is very simple for us because, you know, this is just the power rule for integration. We've got 1/5 u to the 5th minus 1/3 u to the 3rd plus c. No worries. So we found the antiderivative. Now, of course, you can substitute back in. And if you substitute back in, remember u is the square root of x plus 1. So this is going to be 2. And here we have 1/5. Now, instead of u to the 5th, we have x plus 1 to the 5/2. Because what I'm doing is I'm replacing u with x plus 1 to the 1/2. Minus 1/3 x plus 1 to the 3/2. Then plus c. And there you have it. And of course, the thing about this, you could have used substitution and let u be x plus 1. And you would have ended up with a radical in the problem. But sometimes it's nice just to let u be the entire radical.